The Spanish galleon cut through the turquoise Caribbean waters, its crew weary from months at sea. A successful catch of barracuda promised a feast. That night the sailors roasted the gleaming fish over open flames on deck, its rich flesh a welcome change from salted pork and hardtack. Within hours, a strange unease settled over the men who had eaten most heartily. A tingling numbness began at their lips and fingertips, a creeping pins and needles sensation that defied explanation. Then came the true horror. A sailor, parched, reached for a ladle of cool water from the barrel. As it touched his skin, he recoiled in agony, screaming that it burned like fire. Others confirmed the nightmare. Cold objects now seared their flesh, while warm ones felt unnervingly icy. The ship's surgeon, baffled, documented the escalating symptoms in his log. Profound weakness, crippling abdominal cramps, and this terrifying sensory reversal they called cold allodynia. The poison had hijacked their nervous systems. For weeks, the afflicted men suffered, their bodies trapped in a world of inverted sensations, a mystery illness with no visible cause, born from the very sea that sustained them. The logbook of William Anderson, surgeon aboard a British naval vessel in the Pacific, lay open on his chart table. His pen scratched across the page, recording the aftermath of a feast days prior. The crew had celebrated a large catch, a magnificent red snapper. Now men groaned in their hammocks below deck, their bodies seized by a deep grinding ache in every joint. Anderson moved from man to man in the dimly lit berth, his fingers pressing gently against swollen wrists and ankles. He documented each symptom with clinical precision. Beyond the pain, the sailors complained of a persistent coppery flavour coating their tongues, a metallic ghost of the meal that refused to fade with water or grog, haunting them for weeks. This was no simple case of bad fish or spoilage. Anderson's meticulous notes captured a distinct syndrome, the arthritic agony and that peculiar, lingering taste. His records, sent back to England, became one of the first detailed clinical portraits of the poisoning, a puzzle piece for future investigators staring at the same mysterious symptoms across the oceans. The mystery that had plagued sailors for centuries finally found its source not in the fish, but in the very reefs they swam above. On the sun-bleached skeletons of dead coral, a microscopic world thrived. Tiny single-celled organisms called dinoflagellates clung to the algae, their golden brown cells shimmering in the shallow tropical light. Among them was a specific species, Gambia discus toxicus. To the naked eye, it was invisible dust, but within its cell, a complex chemical factory was at work. Using sunlight for energy, it synthesized molecules of extraordinary potency, ciguatoxins. These were not waste products, but potent neurotoxins, the genesis of all the suffering to come. When the reef was healthy, their numbers stayed in balance. But when coral died from storms or warming seas, the algae bloomed, and with it, the population of Gambia discus exploded. A toxic film coated the underwater landscape, waiting to be grazed upon, turning the reef itself into a silent, poisonous garden. While the dinoflagellates clung to the reef, the poison's journey was just beginning. Small grazing fish like parrotfish and surgeonfish nibbled at the algae, their digestive systems absorbing the invisible ciguatoxins. The toxins dissolved into their flesh, a silent contamination that left no mark on their shimmering scales. With each mouthful of algae, the fish became living reservoirs, carrying a dose that was harmless to them but would concentrate with terrifying efficiency. The contaminated herbivores then became prey. A grouper lurking in the coral shadows ambushed a parrotfish, swallowing it whole. The predator's body did not break down the stable toxin molecules. Instead, it stored them, When that grouper was later eaten by a larger amberjack, the amberjack inherited the combined toxin load from every contaminated fish in the chain. The poison grew more potent with each predatory leap. At the apex of the reef, in the crevices where moray eels coiled, the concentration reached its peak. An eel that had fed for years on toxic fish accumulated a massive dose in its liver and muscles. This was the final deadly step. A large, seemingly healthy predator, its flesh packed with a poison 1,000 times more concentrated than in the microscopic algae where it all began. The poison, now concentrated in the flesh of a grouper, had reached its final target. Inside a sailor's digestive tract, the ciguatoxin molecules dissolved into his bloodstream. They coursed silently toward his peripheral nerves, where millions of sodium channels stood ready to transmit signals. Each toxin molecule was a perfect, malevolent key, searching for a very specific lock on the surface of a nerve cell. When it found one, the ciguatoxin molecule wedged itself permanently into the sodium channel's gate. The channel, designed to open and close in a precise rhythm, was now jammed wide open. A relentless flood of sodium ions surged into the nerve cell. The cell, overwhelmed by the constant electrical current, began firing frantic, chaotic signals down its length. This neurological pandemonium spread like a wildfire through the nervous system. To the brain, these false alarms were indistinguishable from real sensory input. A signal for cold from a hand in water was misinterpreted as searing heat. The command to relax a muscle became a painful cramp. The sailor's own body had been hijacked by a microscopic key that could not be removed. Back in the toxicology laboratory, scientists now faced the poison's most insidious property. They took a fillet from a known contaminated grouper, placed it in a beaker of boiling water, and watched the clock. Hours passed. The fish flesh turned to a grey, flaking pulp, but the real test was yet to come. They extracted liquid from the boiled slurry and injected a tiny, carefully measured dose into a laboratory mouse. Within minutes, the animal's limbs began to twitch, then seize. The violent neurological reaction was identical to that caused by raw, toxic fish. The heat had done nothing. The complex ciguatoxin molecule with its intricate ladder of carbon rings had remained perfectly intact. This heat stability meant every traditional safeguard was useless. Baking, frying, grilling, no kitchen fire was hot enough to break the chemical bonds. A fisherman could not cook the danger away. The toxin hid within the muscle, indifferent to the pan's sizzle, waiting to unleash its chaos once it reached the human body. The mystery of ciguatera, however, remained locked inside a molecule. For centuries, physicians had documented the symptoms, but the poison itself eluded capture. That changed in the sterile glow of 20th century laboratories, where toxicologists armed with new tools began the painstaking hunt. Their target was not a fish or a microbe, but the invisible chemical weapon itself. After years of extracting toxins from tons of contaminated fish livers, a team in Hawaii finally succeeded. In a glass vial, they held the prize, ciguatoxin, isolated for the first time as a pale yellow crystalline powder. It was deceptively beautiful, a delicate substance that could bring a grown man to his knees with a dose smaller than a grain of salt. Advanced techniques like nuclear magnetic resonance then mapped its labyrinthine architecture, a massive, intricate ladder of carbon, hydrogen, and oxygen atoms. This complex, rigid structure explained everything: its potency, its ability to slip past biological defenses, and its stubborn resistance to heat. The ghost that haunted tropical seas now had a definitive chemical fingerprint. In the sterile glow of a modern hospital, a patient who had enjoyed a grouper fillet weeks earlier described a persistent crawling sensation beneath their skin. For doctors, the diagnosis was a process of elimination, ruling out everything from multiple sclerosis to rare infections, until the patient mentioned that ice water now felt scalding hot. That classic symptom, first noted by Spanish sailors centuries prior, pointed unmistakably to ciguatera. There was no magic bullet, no antidote to neutralize the toxin already woven into their nerves. Treatment became a battle of management. The most common protocol involved a slow intravenous drip of mannitol, a sugar alcohol, which could reduce nerve swelling and alleviate the most acute neurological firestorms, offering a critical window of relief from the body's own electrical storm. But for many, the poison's grip was tenacious. Long after the mannitol bags were empty, a deep, bone-aching fatigue could settle in. Victims reported that the ghost of the toxin would reawaken, a sudden flare of nerve pain, a return of that metallic taste, triggered by something as simple as a cup of coffee or a stressful day, a recurring echo of a single meal that could haunt them for years. For centuries, without understanding the toxin itself, coastal communities developed their own defenses. In the Caribbean, fishermen passed down generations of hard-won wisdom. They learned to avoid barracuda with unusual markings, or those caught after violent storms had churned the reef, moments when the invisible threat seemed to rise from the disturbed seabed. This traditional knowledge became a cultural map of safety. Elders taught that certain fishing grounds were taboo during specific seasons, and that the liver of a large grouper should never be eaten. These rules, born from observation and suffering, formed a fragile but effective barrier against the poison lurking in their daily catch. Today, in bustling port markets from Miami to Tahiti, a different kind of vigilance operates alongside tradition. Expensive chemical test kits, small immunoassay strips that change color, now screen high-risk fish before they reach the ice-filled stalls. It is a modern, scientific layer of protection, yet one that remains out of reach for many isolated islanders who still rely on the old ways. For centuries, ciguatera had been contained to tropical reefs, but the world was changing. In the late 20th century, marine biologists noticed a troubling pattern. As coral reefs bleached and died from pollution and warming seas, the bare surfaces provided a perfect new home for the toxic dinoflagellate, Gambia discus, to colonize and bloom. The blooms spread. Warmer water temperatures, once a barrier, now became a welcome mat. The microscopic organisms drifted on currents, hitching rides to new coastlines. In laboratories, researchers watched as samples from temperate waters, once clear, now teemed with the distinctive toxic cells under their microscopes. The poison followed. Medical reports began trickling in from places like the Mediterranean Sea and the Canary Islands, regions where ciguatera was a medical curiosity, not a local threat. Fishermen and tourists, eating locally caught fish, were experiencing the classic bewildering symptoms: the burning cold, the tingling lips, the reversal of sensations.